Hey everyone. So let us talk about this lead code problem. Guess number higher or lower. So we are playing the guess game. The game is as follows. I pick a number from 1 to n. You have to guess which number I picked. And every time you guess wrong, I will tell you whether the number I picked is higher or lower than your guess. So there is a guess API that is given to us. Okay, and it returns three possible results. -1 if your guess is higher than the number, 1 your guess is lower than the number, and 0 whether your guess is equal to the number. And then you need to return this number. Okay, so basically you are given n some range. Okay, and then you need, and the computer, let's say, picks some number over here, let's say 3. Okay, so you need to guess from 1 to n this number 3, and you are given this guess API, okay, in which you pass the number, and this API returns either -1, 1 or 0. In case if it returns 0, that means you guessed it correctly, and then you need to return this number. Okay, so one thing that we can do is we can run a for loop over here on this entire range from 1 to n, and then check for each number. And if that each number in the guess API returns 0, that means we directly return this number and then say that this is the number that the computer has picked. Okay, but this is a very good example of binary search. So if you just run this a for loop, you will get a time complexity of O of n, but using binary search, we get a time complexity of O of log n. Okay, in this what we do is we pick two pointers, low and high. Okay, then we calculate the uh, middle and then check this mid in the guess API. Okay, and why binary search works over here is because we have a sorted array. We have a range from 1 to n in which we need to guess the number. Okay, now if we have picked this mid, this number, and we pass it to the guess API, if the guess API returns 0, that means we have selected the correct number, which the computer has picked. But if the guess API returns -1, that means we have guessed something which is very high, and we need to guess in the low area. Okay, from in this range. That means we have completely discarded the search in this range. In case if the guess API returns 1, that means we have picked something which is lower and we need to pick a higher number. And then our search is between this area and we discard the leftmost area. Okay, so that way our algorithm returns in O of log of n time, and this is a very good example of binary search. Okay, so let's just write the code and see how it looks. Okay, so we'll create first two pointers, low and high. We have to run a while loop while low pointer is less than equal to high. Okay, now we need to guess a number. Okay, so we'll pick this number. We find a middle element. So we say low plus high minus low divided by 2. Okay, so we use this formula to calculate the middle number. Basically, we could have just said low plus high divided by 2 to get the mid. But there could be a chance wherein low plus high would be an integer overflow. That the result of low plus high would be an integer overflow. That is why we are using this formula. Now, in JavaScript, division would return decimals. So, okay, so we need to return the digital out of it. Sorry, the integer out of it. We don't want the decimals. So that is why we are using math.floor. Okay, so now we have picked this number mid. Let's pass it to the guess API. Okay, so now this guess API will return either -1, 1 or 0. Okay, so if the guess API returns -1, that means your guess is higher than the number that is picked. Okay, so we need to search in the lower range. So we have to reduce our high pointer. Okay, now if our guess API returns 1, that means we have picked a lower number, we need to pick a higher number. That means we need to move our search in towards the right hand side. So we say low is equal to mid plus 1. And if our guess API returns 0, that means we have picked the correct number that the computer has guessed, so we return the number. Okay, so let's just run this on the test cases. All right, so we got an acceptance on the test cases. Let's submit it. Okay, so we got an acceptance.